Hello, and welcome to the next video in this lesson about debugging tools. In this video, we're going to introduce you to the concepts of logging, and in particular, logging with Android's Logcat. First of all, what is logging? Logging is the process by which you create a log file. Therefore, obviously, this leads to the question of what is a log file? And it is a record of events that happen on a system. Specifically, in Android, it is a record of system messages that both the Android platform and the apps create while they are running. These system messages can be a variety of things, ranging from error messages, notifications, and even custom messages that a developer can write to help them examine their app's runtime behavior. As a developer, you'll also be able to write these messages. You just need to learn the specific statements to put in your source code. Additionally, Android Studio comes with special tools to help you efficiently read and filter these messages. Therefore, in this video, we'll introduce you to the statements that you'll need to use to write log messages. We'll discuss what log levels are and how they impact logging. We'll go over how to read the log file and how to filter the output of the log. And we'll discuss some good practices for you to use when writing your own custom log messages. To demonstrate how to log your app's runtime behavior, I have written a simple application that does nothing other than display some text when the on-screen button is pressed. I will show you some simple source code that will demonstrate how to log information from your app while it is running. First, we must include the following line at the top of our class file with the other import statements. This line will be explained in greater detail in another lesson, but for now, we include it to tell the source code which library or set of code to actually use for the log statements used below. Before we get to the log statements just mentioned, let me first show to you and describe another line that is important. This line, which you can see now inside the red outlined zoom box, is where we create a local variable that identifies the class file from which the log statements will come from. This is important later in larger projects that have multiple class files for two reasons: because it allows you to quickly identify where a log statement came from, and because it allows you to filter out log statements that don't come from a particular class file if that is what you want. Both of these really help make the process of debugging runtime behavior easier and faster. Now, let us scroll down to where the log statements are. You will see a method called button pressed. This method is ran when the on-screen button is pressed. Therefore, we have log statements at the very beginning and end of the method that will log when the method starts and stops. Additionally, we have a log statement after the on-screen text view has its text changed. Now, let us examine one of the log statements in more detail. We'll first look at the one at the beginning of the method. You can see this easier in the red outlined zoom box. This statement starts with log, has a .i, which I'll explain in a minute, then has, in parentheses, two strings. The first is log tag, which references the string above that says which class the log came from, and the second, which is in green, is the output which we wish to be in the log. Now, let us examine the second log statement. This one is similar to the first, but you'll notice some differences. The first being that after the log in the very beginning of the statement, you will see a .v, where in the other statement it was .i. This indicates which log level the statement should be associated with. Android has 6 log levels: assert, error, warn, info, debug, and verbose. The first letter of these words are used to indicate what level you want your log statement to be declared as. So, .i is an info level log statement, and .v is a verbose level log statement. Log statements exist in many programming languages and help the programmer to declare what the severity of an individual log statement should be. This also helps in allowing developers to temporarily filter out statements that they don't deem significant at a current time when they are looking at logs. This is done by the log statements having a priority to their severity levels. The log level assert has the highest severity, meaning that if you filter on the assert level, no other logs will be displayed that are below the assert level. Error has the next level of severity, meaning that if you filter on error messages, you will only see messages above or at that severity level, meaning either assert or error. This pattern continues with warning showing warning and the two higher severity levels, error and assert, with info displaying info statements and the three levels above it, error, assert, and warning. Then debug filtering shows debug and the previous levels, and verbose has the lowest level severity, meaning that if you filter on that level, you will see all log statements. Getting back to the log statement we were previously examining, it has the log tag variable as its first string, which indicates it is from this class. Then it has a string in green similar to the previous log statement. However, after that green text, it has a plus sign, then the string value variable. This will include the values stored in string value into our log statement. This is how you log values of variables, which is very useful when examining your app when trying to fix some kind of logical error in your source code that is producing incorrect output. Being able to look at a sequential log of log statements and the values that variables stored at the time helps you build a better mental image of the runtime behavior of your app. Now, let us run the app and examine how you do the filtering I was mentioning previously. I have an emulator running in the background, and I will launch the app on that emulator. This will open up the Android Monitor window and display the Logcat tab, which is what we want. I will click and drag this window up to give some more screen space for it to use. Now I will bring the emulator to the front, and it is currently running. I will press the button and the text will change. We will go back to Android Studio Editor and look at the Logcat window. You will see that new lines appeared in the Logcat editor. These relate to the Logcat statements within our application. If we look at the top and towards the center of the Android monitor, we will see what the current log level is set to for the filter. Currently it is set to verbose. This means that all log statements are being shown. This statement right here has a V at the beginning of it, indicating that it is a verbose statement. So if we select debug in the filter selection, that statement will disappear. The same is also true if we select info, then the debug statements will disappear. This pattern continues. If we select warning, then only warning and above are shown. If we select error, then no statements are shown because there are no error statements within the current log. The last thing we'll discuss in this video is the search bar next to the log level. This allows you to search for particular text strings in log statements. This is useful when you know what log statement in particular you are looking for the value of, and can then search for that. As an example, let us enter the word changed, and we will only show the log statement showing the value that the text was changed to. You can narrow the search down to a particular class by entering that file's name if its log tag is set to the class name. So for example, main activity. You can easily find all the main activity log statements that way. I will now go back to the emulator and click the button a couple of times to show you another property of viewing logs within Logcat that you should be made aware of. You will now notice that all of the logs are in order and that there is no clear separation visually between different button presses. And for that matter, the same would be true for you running your app multiple times. The logs would just run together visually, which is why it is a good idea to put log statements in the beginning of key methods, so that you can identify when new executions of that part of your application have started. So for example, we put in button press called, indicating that a new button press started then. Hi, and now that you've completed this video, you should understand how log statements are written and how to write your own. You should understand what log levels are and the impact they have on filtering. You should be able to use Logcat to read the log from a device and even how to filter the output. And you should understand how the practices of consistent logging, especially the beginning of key parts of your app, can help make reading logs easier and more efficient.